We're going to look at transformations and circles. So you can see in our diagram, I have circle A over here, where the center is located at -3, 2, and we have a radius of 1, 2, 3, 4 units. It says use the following transformations to create images of circle A. Draw them on the graph above, or in this case, to the left. So it says first we're going to translate circle A. And as a reminder, translate means a slide. So we want to translate using this vector. And if you remember, this is the component form of the vector. This first number here tells us if we're moving left or right. So because it's positive, that means we're going to shift the circle right 4. And then the second number here tells us our up or down movement. So since it's negative, this means that we are going to move down 3 units. So we're going to create this circle over here, and we're going to label the new circle, circle B. So the easiest way I would say to do this is to just translate the center of circle A, and then we can use that radius to draw in the rest of it. So we want to move right 4, 1, 2, 3, 4, and down 3, 1, 2, 3. That means this will be the new center of our circle, and we said that we're going to call it circle B, so I'm going to label that B. And a translation doesn't change the size of the shape. It's just shifting it left, right, up, or down. So that means I'm going to keep that same radius of 4 units. So from the center point to the right 4 units, this point would be on the circle. Up 4 units, this point would be on the circle. To the left 4 units, and then down 4 units. All of those points would be on the circle. So you're going to see my awesome drawing skills. I'm going to do my best to draw a circle. And we're expecting that it looks to be the same size as circle A. So there's circle B, which is just a translation of circle A. Now we're going to dilate circle B. So this red circle here, we're going to dilate that by a scale factor of 2, about that center point. So we're going to use this center as our center of dilation. Now, as a quick reminder, when we're talking about a scale factor, the scale factor, we always have new over old. So in this case, when we're saying it's 2, that's the same thing as saying 2 over 1. We're essentially saying the new circle is going to be twice the size of the old circle. So really all this means is that we want to double the size of the circle, but keeping it centered at point B. So that means in order to double it, typically when we're talking about similar figures, we're used to saying different side lengths. So the ratio of the side lengths. Well, here it's really hard to say the side lengths because of it being a circle. So instead, let's talk about the radius. The radius should now double. So instead of a radius of 4, we want a radius of 8. So our new circle will still be centered here, and we're supposed to call this circle C. So that means this point, not only is it point B, but it's also point C. And we want to double our radius. So instead of going 4 units to the right, we actually want to go 8 units to the right. And instead of 4 units up, we want 8 units up. 4 units left of the center is now 8 units left. And instead of just going 4 units down, we want to go 8 units down, which means now this is our new circle. And again, I'm sure you're doing a much better job at drawing this and actually making it look circular. And there we go. So we have our circle C here is green, the circle B is red, and then the circle A here was our original one. So let's answer some true or false questions. True or false? Circle A is congruent to circle C. Remember, congruent means that they would be the same size. Obviously, circle A and circle C are not, so this would be false. True or false? Circle A is similar to circle C. Remember, the word similar means same shape, but a different size. And I would say that this is true. both of these are circles, right? This is a circle and so is the green one, but they are just different sizes. In fact, all of these circles are similar. All circles in general are similar to each other. And you can always map one circle onto another using translations and dilations. So we're going to explore this a little bit further. It says, which of the following could be a series of transformations that would map circle A onto circle M? Circle all that apply. So first we have that we're going to translate circle A by this vector, which tells us that you would be moving right 9 and up 6. So right and up. So right 9, we're going from circle A to circle M. So right 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2, 3, 4, 5, 6. So I agree with this part. Then we dilate about center M. So now we're going to be sitting here and we will dilate by a scale factor of 1/2. So remember, the scale factor has to be new over old. So the original circle over the new circle over the original circle. So we're going to talk about the radius. The radius of the new circle was 2, and of the old original 1, 2, 3, 4 was 4. 2 over 4 does simplify to 1/2, which means I agree that part A would work. Part B, translate the circle -9, -6. Well, if we're going from A to M, then that means that we'd go left 9 and down 6, but that's not going to work to go from A to M. So B isn't going to work. Letter C says dilate circle A about the center A, so keeping it where it is, by a scale factor of 2, and then translate by that 6. So if we dilate by a factor of 2, remember something that's bigger than 1, that's going to make it bigger. So this would be saying that the new over the old would be 2 over 1 for new over old. So if this is the old one, the new one would be even bigger. Well, clearly circle M is not any bigger, so it's not going to be C. But instead, if we dilate circle A around its center by a scale factor of 1/2, okay, well that is going to make it have that radius of 2 instead of 4. So it would look something like this if we were to draw that in. And then we translate 9, 6. So going right 9 and up 6, and it would land on top of M. So A and D both are going to work here.